Hey everyone, welcome back to another TxePrep video, and in this video we're going to talk about the USACO 2019 January contest Silver Division problem number 2, Icy Perimeter. So let's just start off by reading it. Farmer John is going into the ice cream business and he has built a machine that produces blobs of ice cream, but unfortunately in somewhat irregular shapes. He is hoping to optimize the machine to make the shapes produced as output more reasonable. The configuration of ice cream output by the machine can be described as using an n by n grid, where n is between 1 and 1,000, as follows. So, like we're given a diagram here. Each dot character represents an empty space, and each hashtag character represents a 1 by 1 square cell of ice cream. Unfortunately, the machine isn't working very well at the moment and might produce multiple disconnected blobs of ice cream. A blob of ice cream is connected if you can reach the ice cream cell from every other ice cream cell in the blob by repeatedly stepping to adjacent ice cream cells in north, south, east, and west directions. Farmer John would like to find the area and the perimeter of the blob having the largest area. The area of the blob is just the number of hashtag characters that are part of a blob, and if multiple blobs tie for the largest area, he wants to know the smallest perimeter among them. In the figure above, the smallest blob has an area of 2 and a perimeter of 6, while the larger blob has an area of 13 and a perimeter of 22. So over here we see that this small blob has a perimeter of 2 and this larger blob over here has a perimeter of 22. Note that a blob could have a hole in the middle of it, empty space surrounded by ice cream, and if so, the boundary of the hole also counts towards the perimeter of a blob. Blobs can appear nested within other blobs, in which case they are treated as separate blobs. For example, this blob is has an area of 1 and is nested in a blob with an area of 16. Knowing that both the area and the perimeter of the blob of the ice cream is important, since Farmer John ultimately wants to minimize the ratio of the perimeter to the area, a quantity he calls the Icy Perimetric measure of his ice cream. When this ratio is small, the ice cream melts slower since it has less surface area to its mass. The first line of input contains n, and the next n lines describe the output of the machine. At least one hashtag character will be present. Please output the one line containing 2 space-separate integers, the first being the area of the largest blob and the second being the perimeter. If multiple blobs are tied for the largest area, print the information for whichever one of these has the smallest perimeter. Alright, so now let's actually look at the sample over here and let's see how we can calculate the perimeter and the area. So now we will do exactly that. So this is our blobs of ice cream over here. So this is exactly similar to what we had over here. This is exactly the same thing as over here. So we notice that there's one blob with an area of 2 and one blob with an area of 13, which is as mentioned before over here. So now that we see that this area has a blob of 2 because there's 2 connected components, and in this, if we count it, we would end up with 13 total connected components. So in order to find this, we can actually just use flood fill, since we can easily see that it says that it must be in an adjacent, the next blob must be adjacent to it in north, south, east, or west, and that sounds perfect for using flood fill. And the interesting part over here would be to find the perimeter. And in order to find the perimeter, we can just count basically how many times our flood fill stops. So let's say we start a flood fill over here, right? So if we start over here, then our flood fill, what it will do is, first let's say it goes to the right, and then after that it goes from here and then it goes to the right again, but no, it notices that this is empty space, so it stops. So we can increment our counter by 1, then it goes down, but we notice that that's also empty space. So then that will break from that specific flood fill. Then we can go up, but we notice that that is out of bounds, so then our counter is incremented again. Then since we finished the flood fill of this, we go back to the flood fill of this. So now we go down to check, but that's an empty space, so we know that it increments. And then we go to the left, we check, okay, that's out of bounds, so then it increments, and we go up again to check, okay, that's out of bounds as well. So we see that we end up with a perimeter of 6 by doing flood fill this way, and that is exactly what the perimeter was stated to be before. So this is how we can find our perimeter. So now let's actually try programming this. So over here, I have set up the input files and the output files, and then let's just start with it. So the first thing I'm going to do is include bits, standard C++, and then I'm going to use namespace standard if string. Then perimeter, and our name for this is perimeter.in, which is over here, perimeter.in. And our offstream, which is how we're gonna output the file, is under perimeter.out. So now what I'm gonna do is actually start keeping track of the values that we need. So we want to keep n. Then we also want to keep a string of our graph. And it doesn't have to be a two-dimensional thing, because we notice here that there's only 6 strings. We can count each one of these rows as a string, so that we know that there's only 6 strings. So we can say a graph of size of the maximum amount of n, which in this case would be 1000. So I'm going to put size of graph 1000. And then what I'm going to do after that is I'm going to create a visitor array. So bool viz 1000 by 1000. And then I'm going to do in perimeter is equal to 0. So this is going to be our perimeter when we're going through flood fill for each specific cell. So in perimeter, in area. So those are our 2 values. And then what I'm going to do next is create like the main method, so we can just run it from there. So the first thing I'm going to do is input n. Then I'm going to input the graph. So for in I is equal to 0, I is less than n, I plus plus. I'm going to input the graph at I. Then what I'm going to do next is create 2 values, int max area, and which I'm going to set to 0. And then I'm also going to create max perimeter, and I'm going to set that to 0 as well. What I'm going to do next is actually now iterate through every single cell in the graph, and do a flood fill on that. So I'm going to say for int I is equal to 0, I is less than n, I plus plus. And I'm going to say for int j is equal to 0, j is less than n, j plus plus. So that's basically just iterating through every single cell. I'm going to say that if the graph at that specific point is a hashtag, which represents our ice cream, then, and it's not been visited before, then what I'm going to do is actually perform flood fill on it. So flood fill I, j, and I will create the method right now. So we can go over here. So I'm going to create a void flood fill, and I'm going to pass in two integers, int x and int y, basically just the x and y coordinates of our thing. And then this is how I'm going to help calculate the perimeter. So I'm going to say if x is less than 0, x is greater than or equal to n, or y is less than 0, or y is greater than or equal to n, or if the graph at that specific point contains x or y, that contains a dot, like the dot that represents an empty space, then what I'm going to do is increment the perimeter, because we talked about having our perimeter increment every single time that our flood fill would break, because it was either out of bounds or it reached a dot. So that's when I'm going to increment the perimeter, and obviously I'm going to return to like break the flood fill so we don't continue forever. And otherwise, if we realize that it's already been visited before, then we're also going to return. But in this case, we don't want to increment the perimeter, because otherwise we might end up with a result that's a bit too much. And then what we're going to do next is we're going to set visitor x and y to be true, just to make sure, just to mark that we've been visited. And we're going to increment area. And the reason we increment area is because we have entered a new hashtag cell. We've entered one of those hashtag cells, and we see that, okay, we have an area of 2 because there's 2 hashtags. So that's why I want to increment area. And then after that, I'm going to say for int I is equal to 0, I is less than n, or I is less than 4, I plus plus. What I'm going to do now is actually create an array just so that we can make like a nice flood fill thing. So we can say const int, I'm going to call it xd. And these are just the different directions of x, so 0, 1, 0, xd4, is equal to, and in an array 0, 1, 0, and negative 1, and you'll see why I do this pretty soon. And then y direction of 4 is equal to, in an array bracket thing, 1, 0, negative 1, and 0. And now what I'm going to do now is actually just iterate through these values of xd and yd, and basically just add them to x. So basically it's just the same thing as simulating going up, left, right, or down. So I'm going to say flood fill of x plus xd at I and y plus yd at I. So that's basically just our flood fill, and now that's complete. So we see that we store our area and perimeter in 2 global variables, so we can still check them down over here. So what I'm going to check now, after every single flood fill, is I'm going to check if the area is greater than the maximum area. Then what I'm going to do is set the maximum area to the area, just keep on growing our area, but also change the it should not be max perimeter, it should be the minimum perimeter, which was what we had, min perimeter. I'm going to set the min perimeter to the perimeter that we have in our global variable. But otherwise, if it's equal, then I'm just going to take the minimum of the 2 perimeters that already exist. So otherwise, if the area is equal to the max area, then what I'm going to do is that min per is equal to min of the minimum perimeter that already exists, as well as the perimeter that we found by using flood fill. Okay, and then after each one of these, I'm just going to set flood fill to be, I'm just going to set the perimeter and the area to be 0 to just reset our values. So we can see over here, an area is equal to 0, and there we have it. And then, now that we have calculated everything, we can just simply output all of these values, and then we're done. So, f out max area, and then also the minimum perimeter, so min per. So let's just try running it, and we should notice that we get a output of 1322 on our sample case that I already inputted, so that's what it happens. So now let's see what happens when we submit this code. Alright, so here I am. I'm about to submit this the file and the solution to see what happens. And we see that it's starting to work, and it turns out that it actually does work for all of our test cases. So basically, just to reiterate, what we did in this was we did a flood fill, and then we also stored 2 global variables, perimeter and area, and we changed perimeter based on how many times our flood fill exited, how many times our flood fill stopped, and we incremented area by how many different squares we visited. And then at the end, we checked if area was greater than the maximum area, the previous maximum area, then we would change our maximum area to be the current area and change the minimum perimeter to be the current perimeter associated with that area that we just got from the flood fill. And otherwise, if they were equal, we would just take the minimum of those 2 perimeters, and then we would just output them. So that's basically it for this problem, and I'll hope to see you guys in the next one.